Recording. All right, awesome. So yeah, welcome everybody from around the world, Brazil and Texas, which is like a whole nother country. I know you guys think you are like a whole other country to yourselves. So wherever you're kind of chiming in from, welcome. Definitely looking forward to spending some time with you guys. The way this is kind of going to work, I'm going to exit out of this and kind of go into a presentation mode and just try to get through as much as I can. But I'll leave the chat area up so you guys can ask questions and post them even as I'm going through the kind of the content. I may ask some questions from time to time, so you guys can definitely chime in and answer my questions in the chat area. And then afterwards, we'll be able to come back and I can pull everybody off of mute and we can just stick around and kind of answer any questions you may have at that point. Let me go ahead and start kind of sharing my screen. All right, awesome. So you guys should see my screen at this point. I'm going to leave the chat. Let's see. How do I get the chat? Okay, good. The chat is up. And then I'm going to minimize that. Okay, so I can't see all of your guys' lovely faces, but I can see the chat area. So as you guys have questions, you can post them in the chat area and I should be able to see them as we're going through. And you guys should be able to see my screen, so that's awesome. I think a lot of you guys know me from my time, just kind of some of my videos. I think a lot of you probably found me and Dominate Test Prep through some of my videos, maybe on YouTube, maybe found my website. And I'm excited you're here. This is a topic that I really, really enjoy talking about because it's a topic, probability, that I think a lot of students struggle with, this and combinatorics, right? So you should be able to see me on the screen. I'll use hand gestures and hopefully you can see what I'm doing. But you know, it's really kind of two sides of a coin, right? Kind of on one side, we talk about probability. On the other side is combinatorics. And kind of the principles that I'm going to teach you today with respect to probability really translate well to understanding how to think about combinatorics. We're not really going to have time to get into the combinatoric side of things, but here's what I am planning on doing. I am planning on just dumping like my entire probability course, the probability portion of my course, try to give it all to you as quickly as I can tonight in this 1 hour that we have together. So I'm going to probably talk fast. I'm going to go through the material pretty quickly. You guys take notes as best as you can. If the technology works and the recording works, I plan to send it out after the fact so you can kind of go back and rewatch it and things like that. Because like I said, I will be going quickly. For some of you, it might be easy. You might be familiar with some of this. For others of you, it might be kind of a first look at probability, and that's okay. Just kind of pick up what you can. But like I said, I'm just going to give you as much as I can, and we're just going to kind of dive in. By way of background, just to kind of set the table, though, I know Jennifer is scheduled to take the GMAT in just a couple of weeks, 10 days, I guess. And others of you might be newer on your journey. Okay, good. So Gretchen said she's going to take it in September. If you guys want to type in the chat area, let me know when you're taking it. That'll be helpful. But whether you're on the front end of the journey or the back end of the journey, I mean, the reason you're here is because you have to take the GMAT to get into business school, right? It's a stepping stone. It's kind of standing between you and where you want to get to. I love this cartoon about the Buddhist monk's aspirations being dashed when he failed the MAT, the monastic aptitude test. And that's really what the GMAT is, right? It's kind of that gateway. It's that test that you have to get through to get to business school. And that's exactly where I was going on over 10 years ago now. Hard to believe, but that's me sitting at my first job. So when I graduated from Duke, went overseas, actually lived in Africa for a couple of years, came back and took my first job, which is me here in Washington, D.C., working in public relations and lobbying and marketing in Washington, D.C. for a startup company. And it was a great job and I had a good experience, but came to the point a couple years into that job where I think a lot of you guys probably are now, which is realizing that to get where you want to go, to get where I wanted to go in my career, going back to school made the most sense. And so buckled down, took the GMAT, Went back to school, got a great degree from the University of Denver, a Master's of International Finance. So it wasn't a traditional MBA I got. It was a business degree in finance, international finance from the University of Denver. And I'm glad I did. Certainly had a good experience doing that and has helped me on my career journey. But one of the things that I realized along that journey is something that I now take to the way that I kind of teach the GMAT. And I think you're going to pick up on that during our time together. And I really want to just kind of present it and share it with you, kind of, especially if you're on the front end of your journey and you're thinking about how to prepare, is just understanding that at the end of the day, the GMAT is a means to an end. It's that gateway, that kind of gatekeeper that I was talking about, where you're not taking the GMAT because you really, really want to learn a bunch of triangle rules or remember how to find the area of a circle or learning a whole bunch of probability stuff that you may never have learned back in high school, but now you have to somehow figure out probability on the GMAT. Your goal is just to get a high GMAT score. And so you want to attack the GMAT that way. I remember when I was actually interviewing for my first job to teach the GMAT and the GRE, incidentally, for a leading prep company based out of Denver, Colorado, which is obviously where I was in school. And I thought it would be fun to kind of be in a classroom and teach something that I was pretty good at, the GMAT and GRE, help other people along the journey I had just completed. And I was interviewing for the job to kind of be an instructor, and the guy gave me a quiz, right? So he brought me in and I did a sample teaching session, and then he gave me a quiz of questions to answer. And he left the room and he said, come get me when you're done answering these questions. And so I'm going through all the questions. And I remember I got to a question that was particularly hard. So I had done well, but this question was pretty challenging. And I remember stopping and thinking to myself, like I probably am expected to get all of these questions right. If I'm going to teach this test, I probably should be able to do this stuff myself. So I had this realization that I didn't necessarily immediately know how to do it, but I had to get creative and I had to think about the problem from a different angle. I had to come at it from, in this case, a fairly non-traditional way. And I ended up thinking through it and got a right answer, kind of reasoned my way to a right answer, got them all right, and was hired to teach, and kind of the rest is history. My point with telling you that story, though, is that can happen to you as well on test day, right? So, Jennifer, when you're going to sit there in 10 days from now and a question pops up on your screen, great if you immediately know how to do it, but what if you don't? And we still need to have the calm and the presence to be able to attack it, sometimes from non-traditional ways. And really the point of a webinar like I'm doing tonight is to give you the starting point, the stepping stones, the building blocks to say, okay, I know how to identify a question that I'm looking at, and I know the best strategy to employ on this type of question, right? So that's really what we're going to be doing tonight. That's kind of the mindset that I think you guys should adopt as you're studying for the GMAT. And I just really want to talk to you for just a quick second to position us in kind of time and space as we're thinking about where probability and what we're going to be talking about fits into the larger picture of preparing to do well on the GMAT. Where should you be focusing your time and attention if you want to get the best possible results on test day? And the analogy I like to use is this idea of big rocks. So on your screen you see, and some of you may have seen this demonstration before. I remember I saw it in the context of kind of personal development, and it blew me away the first time I saw this demonstration. Here on your screen you see two jars, right, full of some sand and some rocks, and there are big rocks and little rocks. And in the jar on the left, the rocks don't fit. They're kind of overflowing. They're stacked up on top. They just don't fit. In the jar on the right, all of the rocks fit. And in fact, there's some room to spare. And would you be interested to know that the two jars have the exact same rocks in them? The exact same amount of rocks, number of rocks, it's the same rocks, the same amount of sand, everything is the exact same. But what's the difference? Why don't the rocks fit into the jar on the left? And the answer is that in the jar on the right, they put the big rocks in first. Because when you put the big rocks in first, now you have room for the littler rocks to kind of filter in around, right? And then at the end, when you're just putting the sand in, There's room for all of that sand to filter in. With the jar on the left, they put the sand in first and then the smaller rocks. And by the time they got to the end, the big rocks, there was no room for them. The point is, focus on the big rocks. Put the big rocks in first because that's where you're going to get the biggest bang for your buck. And on the GMAT, I like to talk to my students, and certainly the way I structure my course is, let's focus on the big rocks first and then worry about the small rocks. Now, the small rocks might be the difference between going from a 690 to a 700, or from a 700 to a 710, or for a 710 to a 740 if you're trying to get into Harvard or something like that, right? So I'm not saying the small rocks aren't important, but what I am saying is that a lot of students come to the GMAT and they try to focus on all the small rocks, the really, really hard concepts, or the arcane grammar rules on sentence corrections or whatever. But let's focus first on the big rocks. You might be familiar with the Pareto principle of business that says 80% of our results come from 20% of our efforts. And the same thing happens on the GMAT, where a huge chunk of your success is going to come from just a handful of concepts and strategies and question types. And so if I were to coach you, which I'm doing right now, and especially if you're new to the GMAT, and I were to say, where should you focus your effort? In the beginning, you need to focus on the big rocks. Let's learn the non-standard math strategies. You may have been exposed to them a little bit in some of my free videos that I have on YouTube, the working backwards, making up numbers, those types of strategies. Those are big rocks that apply to so many different question types that can be worth a ton of right answers. Those strategies alone could get you into the 600s, right? It's on the math portion equivalent of that, right? Arithmetic, the most commonly tested topic area, especially percent change and ratios. Algebra, tons of algebra tested. Now, a lot of the algebra can be done in non-standard ways, so you don't have to learn a whole bunch of, setting up algebraic equations and solving for x. You might have to do a little bit of that, but you don't have to do a ton of that, but especially quadratic equations, exponents, those are some big rocks, right? Data sufficiency. Almost half of the quantitative questions you're going to see are data sufficiency. So if you haven't learned yet how to think through them, how to systematically eliminate wrong answer choices as you're making determinations, you're leaving some big rocks on the table, right? You're focusing on the sand when you should be focusing on big rocks. So make sure you learn your data sufficiency strategies, especially the ones that include variables. That's some low-hanging fruit that you can just pick if you learn how to deal with the variables by making up numbers. Triangles are the most commonly tested geometric figure, especially right triangles. That's a big rock. Spend time there. And oh, by the way, now we can think about data analysis like probability and combinatorics, right? So I'm telling you this kind of for a couple of reasons, because I want to help you while you're on your journey, but I also want you to kind of understand where probability fits in time and space. A lot of people are attracted to a webinar like this because, oh, probability, those are like the hard questions. I need to be able to get those right. Yes, you do, but have you focused on the big rocks first, right? But here's where this webinar becomes important, because the probability and combinatorics are some of the smaller rocks, but now they can be the difference between scoring in the low 600s or upper 600s, or scoring in the upper 600s to now cracking 700. So this topic is absolutely important, but just understand kind of where it fits on the scale. I hope that makes sense. So am I making sense? Are you guys, nobody's chatting. Hopefully you're just listening to me. Don't worry, we're about to dive into kind of the meat and potatoes of the probability stuff. So we are gonna get there. Let me make sure you guys are good to go. Okay, yes, Marion, good. Marion's chiming in. Thank you, Marion. All right, so good. So that makes sense. And let's go ahead and dive in. Oh, really quick, I think I mentioned this in the email. I mentioned it's a good idea to show up. I will have a special promotion for you at the end, so be sure to stick around to the very end, including a way that you can possibly get the Little Purple Probability book. It's a great book by a friend of mine named Brandon Royal. So in my course, for those, maybe you've looked on my website at my courses and stuff, for my gold and platinum packages, I'll talk about that later, but I actually include and send a great GMAT textbook called Ace the GMAT by this author, Brandon Royal. So I think he's got some great stuff out there in terms of helping prepare for the GMAT. And he's got this little book, hence the name, the Little Purple Probability Book. That's got some really good stuff in there, including a lot of the stuff that I'll be talking about tonight as well, but some good practice problems and so forth. And so I'll tell you how you can kind of get that for free at the end of this webinar. All right, so let's dive in. So hopefully you guys saw and downloaded the sample questions that I sent out via email. If you're going to be seeing these questions for the first time, that's okay, but you're just going to have to read fast to kind of see what it says. I'm just going to start talking about these questions as if you've already seen them, because hopefully you have. Question number 1, I'm actually going to put on the back burner for a second, and we're going to work through it here in a few minutes after I give you some building blocks. So here's what I'm going to do, right? The purpose of this webinar is to teach you how to answer hard GMAT probability questions, including a really useful formula that will help you on even the hardest types of probability questions that you will see on test day. And this would be an example of a challenging probability question. Right? There's a lot going on here. And this question requires us to apply several different building block concepts first. So what I want to do is I'm going to actually go through what those 3 core formulas are, right? So hold this thought with question number 1. And what I want to do is I need to teach you some foundational stuff first, right? We need to learn to walk before we can run. So just like we want to focus on the big rocks, we also need to focus on the foundation. We need to walk before we then do the really hard types of GMAT probability questions. So that's what I'm going to do. And we're going to start easy, and you might have looked at some of those questions I sent out and said, these are pretty easy, Brett. Yeah, the foundational ones were easy, but then some of the later ones are more challenging, but I think you're going to see how much easier they are once you understand how to think about probability, right? So let's go ahead and dive in. So we have kind of just a basic understanding of probability. The definition, obviously, it's the likelihood of an occurrence of an event over time or successive intervals or trials, right? And it ranges between 0 and 1. So if I don't have a coin, I probably should have come prepared with a coin, but like if we just have a normal coin and we're going to flip it, what's the probability of getting a heads? Well, how likely is it that I will get a heads? Well, there's only 1 heads out of 2 possible sides, so like there's a 50% chance, right? And it ranges between 0 and 1, where 0 is no chance at all, 1 is a 100% chance. And so when we think about the 3 major rules that govern probability, the first rule is the basic formula of probability, right? The probability of something happening is the number of favorable outcomes compared to the total number of outcomes, right? So let me get a pen here real quick, and I'll just kind of sketch this out. So like, what is the probability of getting a heads on 1 flip of a coin? Well, the denominator is the total number of outcomes, right? So how many outcomes are there? Just 2 heads, obviously, or 2 total sides, right? Heads and tails, so heads plus tails. That's the denominator. And the numerator is just the 1 heads, right? And so 1/2 is 0.5, which equals 50%. You can talk about probability a number of different ways, but that's kind of what's going on. Now, you might be thinking to yourself, okay, Brett, this is like so easy and obvious that it's hardly even worth spending time there. But it is important to remember that formula, because what happens when we see a question like this, right? So here's a sample question number 2, which again isn't all that difficult, and yet it's the type of thing where we need to be crystal clear on what's going on in the question. And what is the question itself asking, okay? So here, and again, you guys can chime in the chat area. If you know the answer, go ahead and type it in. If you think you know the answer, maybe you've already worked on these problems in advance. But what do we have going on here? So we have a class of 15 boys, 12 girls. And of those, 9 of the boys and 8 of the girls speak more than one language. Now, here's the question part. If a representative, blah, 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 is to be chosen at random, that just means it's pure probability. What is the probability? First question, how do we know it's a probability question? How do we know it's a probability question? It's not a trick question. Go ahead and type it in the chat area. Yeah, exactly. It asks about probability. But here's the thing. A lot of students, how many ways? Confuse these two. So how many ways is a question that is a counting question? That introduces the idea that we're going to have to do something with combinatorics or counting, right? But I can't tell you how many students I work with who treat how many ways questions like probability questions, but they're not. Or conversely, they treat probability questions like how many ways questions, and they're not. But very simply, it's asking for the probability. And it's specifically asking for the probability of what? That we get a girl who speaks, more than one language, right? So what's the answer to the question? And the key is, what is the denominator in this case? What's the denominator in this question? Okay, so we have a vote for B, Marion, with a question mark. I want you to be more confident than that on test day. So Ryan also thinks it's 8 out of 27. And you guys are actually both right. So like I said, this is an easy question. But I want to get crystal clear. Yeah, Lucas, 27 is the denominator. Why isn't it 17? Right? Why isn't it 17? Because it's asking for the probability if a student is chosen at random from the total population. And specifically, the wording in the question is from the class. And the class is 15 plus 12, exactly. So, and this is where I can't tell you how many times I'll be reviewing a student's practice test or something like that, and they make a careless error on a probability question because they do not read the question carefully enough to understand that they're not just asking what the chances that the girl is chosen out of the people who speak more than one language. No, it's all 27 kids in the class that we're choosing from among. But then the numerator then, of course, is what's considered a favorable outcome. And in this case, it's a favorable outcome is any scenario 1 has to be a girl. So we're either dealing with 12 or 8. And then criteria 2 is who speaks more than one language. So it's not the 12 girls out of the whole class. It's these 8 girls who not only are girls, but speak more than one language. So you guys are exactly right. The correct answer is answer choice B. Again, not rocket science, but it does remind us that we need to really pay attention to the wording in the question. And just remember that the numerator is favorable outcomes, and getting clear in our mind in terms of what counts as favorable. What are we looking for? And in this case, there were 2 things. We now not only needed a girl, but we needed a girl from this group who speaks more than one language. And then, of course, the denominator is total outcomes of what we're looking for, in this case, the entire class. All right, so again, not going to beat a dead horse there, but nevertheless, important just to remind ourselves how rule number 1 works. And rule number 1, let me go back really quickly, is just kind of a basic building block that will not usually be tested on its own. I mean, even this question pretty much just tests that rule, but it's a pretty easy question. So maybe it would be a first or second, early on in the section. But usually, medium difficulty and certainly harder questions will require you to know that rule in the context of the larger question. A lot of the medium difficulty and harder questions come down to rule number 2. And rule number 2 has to do with probability questions where there are multiple outcomes. So not just picking one random representative from the class. What happens if we're going to choose multiple people from the class? Like, by the way, let me go back. Question number 1, right? We're not just asking what's the probability that Harry will be president. No, it's like an or question. Either he will be, like, 2 chances, either a secretary or a treasurer, right? All of a sudden, that makes it more challenging. What about question number 3? And I'll go back and talk about the rule here in a second, right? This doesn't just say what's the probability of picking a yellow marble. That would be super easy. It's saying what's the probability of getting 3 marbles in a row. So probability rule number 2 has to do with repeated iterations or consecutive outcomes. And this now becomes a kind of an understanding that you need to have in your tool belt for medium difficulty and harder questions. And there are 2 situations I want to talk about. The first, let me go ahead and kind of draw this up on the screen. The first is an and scenario. And anytime we have an and scenario, we multiply those things together. So in general, and I always tell this to my students, when in doubt, so if you ever are in doubt as to what to do, like a good guessing strategy, so when in doubt on probability questions on the GMAT, multiply stuff. So that's like a non-scientific kind of definition of what you should be doing. But, and this is like the more systematic rule, but just in general, if you're saying, do I add these? Do I multiply? Like, just multiply them if you're feeling stuck on a probability question. But specifically what we're doing is that if A and B are 2 independent events and we have A happening and then B happening, well, we just figure out what's the probability of A and then multiply it by the probability of B, right? So like, what's the probability of getting a heads if you flip a coin? 1/2. What's the chance of getting a heads twice? Now I have a 1/2 chance on the first flip and then multiply that by the 1/2 chance on the second flip. So you have a 1/4 chance of getting a heads 2 times in a row, right? So easy example. Let me go ahead and clear that. But let's see how it plays out on a slightly harder question. So here we have our question. And like I said earlier, feel free to type in the chat area as soon as you either have an answer or, like I said, maybe you already did it before. But here we have a bag. And by the way, this is what I always like to do on my scratch paper. One of the things I always tell my students is he or she who uses the most scratch paper wins. So as a general rule on the GMAT, you should be using your scratch paper, drawing diagrams, scratching out what's happening, things like that, right? So I would just draw a quick little bag of marbles, and we're told that we have 5 yellows, so yellow is 5. Red marbles are 6. Blue marbles are 9. So here's our bag of marbles. And we're going to reach into the bag, and we're going to pick 3 yellow marbles in a row. What that tells us is we have repeated iterations. But by the way, even if it didn't say in a row, if it just said we're going to reach into the bag and get 3 marbles, the outcome is going to be exactly the same, right? So whether you literally are picking 3 marbles at the same time, or you're picking one and then picking another and then picking another, it's the exact same outcome. The only way it wouldn't be is if you are replacing it. I'll talk about replacement here in a minute, but this question clearly says we're going to pick out a marble, a yellow marble, and we're not going to put it back in the bag. And then we're going to pick another marble, and then we're not going to put it back in the bag. At that point, what happens? All right. So what's the deal with this? So we want the probability of a yellow and then a yellow and then a yellow, right? And notice how I wrote that. A lot of people would say the probability of 3 yellows. That's the exact same thing, except I like to do this because it reminds me that an and scenario I multiply. So what I'm really going to do is I'm going to figure out the probability of getting a yellow, and then I'm going to multiply that by the probability of getting the next yellow, and then I'm going to multiply that by the probability of getting the next yellow. Does that make sense? So even just a subtle thing like that on your scratch paper can be a huge difference in terms of making sure you don't get lost or confused about what you're trying to do. It's kind of translating what does 3 yellow marbles in a row means. It means yellow and then another yellow and then another yellow, and you remind yourself what to do. All right. So what's the probability of getting a yellow marble on the first pick, right? This goes back. Okay, good. So Marion already has answer choice A. So Marion, what was the probability? And this is where rule number 1 comes into play within a harder question, right? Because we have to use rule number 1 in the context of this question, because the individual probability of getting a yellow marble is favorable outcomes over total outcomes. So how many favorable outcomes are there? What counts as a favorable? Very good. Yep, 5/20ths. We could reduce it to 1/4. We'll see how that plays. But yep, I'm going to keep it as 5 for now. And the reason is just because it just helps remind me that we have 5 total yellow marbles, and those are our favorable marbles, out of 9 plus 6 plus 5 equals 20 total marbles in the bag. So 5 out of 20 is the probability of getting a yellow marble in the first pick. And then multiply. Now what's the probability of getting another yellow marble? And here's where the replacement issue comes into play, right? If we are not putting that yellow marble back in the bag, how many total marbles are in the bag at this point? Yeah, Emma and Dean, you're right. You're exactly right. Right? So the number of marbles have gone down by 1 because I'm assuming I did get my yellow marble. So now it's like there are 4 yellow marbles in the bag. Not, it's like there actually are, right? I just got a yellow marble. So now there's only 4 yellow marbles in the bag out of only 19 total marbles. And you can see kind of what goes on from here. So then on the third pick, there's even 1 fewer yellow marble, 3 only left in the bag, 18 only total marbles at this point. And now I'm going to multiply all of those, right? So that's it. And then we multiply that. And then as Marion figured out, you don't have a calculator on the GMAT, so let's actually make our lives easier. Let's reduce 5/20ths to 1/4. Let's reduce 3/8 to 1/16, right? Or sorry, 1/3. Oh no, sorry, 1/6. 3 goes into 18 6 times. Yeah, 1/6, right? So now we have 1/4 times 4/19, and actually the 4's cancel. So really what we have is 1/19 times 1/6, so it's 1/19 times 6. And you can either do that math or realize 20 times 5 is 100. But it's not that, so it's not 1/100. And it's certainly something a lot bigger than 20 or 4 or 4. So it's going to be answer choice A. You wouldn't even have to actually do the math of 19 times 6 if you wanted to save yourself a little bit of time on test day. So those are just little kind of shortcuts and tricks to help you save a little bit of time, which is precious on the GMAT. But any questions about how that works and how the question might or might not be different with replacement versus without replacement or anything like that? You guys good there? Okay, good. Em and Dean say yes. If you're not communicating with me, I'll assume you're good to go. All right, so awesome. So that is the and situation. But now what do we do with an or situation? Because sometimes we'll have repeated iterations, but we're not asking about getting like 2 heads in a row, like 1 heads and then another heads. Maybe we're asking about, we want to get something or something else, like we're going to have to do with the question number 1, with Harry becoming, either secretary or treasurer. Or, so what do we do with or? And the answer is we add them. So and equals multiply. So and means multiply, or means add. Right? So very simple rule. Like if I were going to break these rules down, and you'll, if you have seen any of my other videos or take my course or anything like that, you're going to realize I hate formulas. I hate formulas. So the formulas are here because it's a formal webinar and so forth. But at the end of the day, let's break things down into easy to understand terms. And means multiply, or means add. So in this case, if I have the probability of A or B, I'm just going to add the individual probabilities A plus B, right? So that's kind of all that's going on here. So hold on, let me advance the slide. All right, so what does that look like here? Now, this obviously isn't a formal GMAT question. I'm just asking you to kind of come up with the answer on your own. But, you know, nevertheless, here it is. And so, again, I'm going to go fast through this because this is super easy, but this would be an example. Like, what's the probability of getting a 2 or a 4, right? So it's the probability of 2 or a 4. Yeah, exactly, Ryan. This would be an example of like a super easy question that you wouldn't even see on the GMAT. It's so easy, but I'm teaching you the concept so that we can apply it to a harder question. It's the same thing as the probability of 2 or plus the probability of getting a 4. And obviously on a normal 6-sided die, what's kind of going back to rule number 1, right? Again, rule number 1 is like so easy we don't even realize we're applying it sometimes, but that's technically what we're doing, right? What's the probability of getting a 2? Well, there's only 1 2 on the whole die, so 1 favorable outcome out of 6 total outcomes. So technically, I am applying rule number 1, even though it's so easy and intuitive just to know that the probability of getting a 2 is just 1/6. I've got 1 chance out of 6 sides, so it's 1/6. Likewise, with a 4, I've got a 1/6 chance of getting that 4. So together, I have a 2/6 chance or 1/3 chance of getting a 2 or a 4. And by the way, I also could have technically just used rule number 1. So rule number 1 and just said favorable outcomes, favorable over total. In this case, how many count as favorable outcomes? Now I have 2 favorable outcomes, either a 2 or a 4. So I actually have 2 favorable outcomes out of 6 total outcomes. That's still just 1/3, 2/6, right? So I can kind of get there faster using rule number 1. That's all we're doing is just figuring out the numerator by essentially adding them together. So that's what's going on here. Now, in this case, right, in the case of getting a 2 or a 4, I can't get them at the same time. It's impossible to roll a die and get a 2 and a 4 at the same time. Does that make sense? So I literally am just adding them because I can't have them both at the same time. But notice kind of the caveat in this rule says if events A and B are mutually exclusive. So mutually exclusive, again, just means I can't have them at the same time. I can't get a 2 and a 4 at the same time. But what if the events are not mutually exclusive? Meaning it is possible to have them at the same time, have them happen at the same time. Then in that case, you add them together, but then subtract out the overlap. So it's the probability of A plus the probability of B. That's where we stopped in the last example. But if the events are not mutually exclusive, like there's a chance that they could overlap, I have to subtract out that overlap because I don't want that to count. And the way I like to think about it, let me go ahead and kind of write this. The way I like to think about it is so in this question, question number 5, we're going to pick now 1 card out of a standard deck of 52 playing cards. What is the probability that you will draw either a queen or a heart, ... but not both? Now, those words won't be in the actual question. So it would be very rare for you to see a GMAT question that would actually include those words, but that is implied. So here I have a situation where I want the probability of a queen or a heart. Let's draw a picture of a heart. Queen or a heart, but not both. In other words, in this case, I need the probability of a queen plus the probability of a heart. But I don't want, so I'm going to subtract out the queen of hearts. And that's where this question's a little bit different because it is possible to have both. There is a card, 1 card in the whole deck that is the queen of hearts. And we don't want to include that one, right? So that's just the difference if they're not mutually exclusive. right? So that's kind of the final teaching here. Quickly, what would the actual answer to this question be? Not 1250 seconds, Ryan, close. So by the way, the GMAT will not ask you like playing cards questions or blackjack questions or rolling dice questions. They don't really like gambling. They probably have to be above board. So you're most likely to see, you know, marbles in a bag, or those types of probability, or like the one we're going to do here in a minute, question number 1. So if you don't know the situation with playing cards, that's okay. You don't have to learn it for the GMAT. But yeah, Ryan, you're exactly right. So again, individual probability of queens. Rule number 1, again, whether we think we're applying the rule or not, that's technically what we're doing. How many favorable outcomes are there? Well, there are 52 total cards, we're even told that, in a deck of playing cards. And how many queens are there? And this is something you may or may not know, whether you play cards or not. But in a standard deck of cards, there are 4 queens. One queen of each of the 4 suits. So 4 queens, plus then the individual probability of hearts. Same thing, 52 total cards. How many hearts are there? Ryan already wrote it up on the chat area. There are 13 hearts because there are 13 of each of the 4 suits. 13 times 4 is the 52 cards. So a wrong answer would be 4 plus 13 equals 1750 seconds, right? So 1750 seconds would be the wrong answer because we need to subtract out the 1 out of 52 cards in the deck that happens to be the queen of hearts. So it would actually be 1750 seconds minus 150 second equals 1650 seconds, or a fractional equivalent thereof. So Ryan, you got it. M&D, and you got it early on, but just kind of a reminder that that's a variation of the OR rule to just kind of think about as you're answering questions like that. All right, so I'm gonna have to speed up here a little bit. I'm being a little bit wordy tonight. I apologize, but hopefully you guys are learning something. And like I said, we're building the foundation that now we're going to have all the tools in our tool belt, right? So rule number 1 is like a screwdriver. Rule number 2, with a couple different variations, might be like a couple different kinds of hammers or wrenches, like or different size wrenches. And now here's the 3rd rule. And this is the one I'm most jazzed about. And in fact, when I talked about in my email, kind of promoting this webinar, saying, hey, the number 1 formula that is crucial for hard questions on hard probability questions, this is the most useful formula. And the formula is that the probability of something equals 1 minus the probability of not something. And this is a formula that's actually useful on super easy questions, but then also on really hard questions. And here's what I mean by the super easy part. Let's say I tell you that there is a 40% chance of rain tomorrow. What's the chance it's not going to rain? So there's a 40% chance of rain tomorrow. What's the chance it's not going to rain? 60%, right? Like, it's so easy, you couldn't even believe I was asking you. You didn't have to do any sort of math. You just know that if there's a 40% chance of rain, there's a 60% chance of not rain. Because we know that they have to add up to 100%. So really what we did is that the probability of rain, equals 1 minus the probability of not rain. And sure enough, those would equal each other. So you definitely do not need the formula for a super easy understanding like that, but we do need it for harder questions like this, right? So now we're kind of getting into the world of harder questions. Question number 6 says, okay, the probability is 1/2 that a certain coin will turn up heads on any given toss. If the coin is to be tossed 4 times, what is the probability? Now here's some wording we haven't seen yet. It's not an and situation. So and, remember, we multiply. It's not an or situation where we add. This is an at least situation. And an at least situation, on at least one of the tosses, I use the complement rule. And the complement rule is the one that I just taught you. So the complement rule I use on at least questions. I also use it on at most questions, like question number 7. So at least and at most questions, right? So here's your little cheat sheet for probability on the GMAT, right? At least and at most, these are the hard ones, or harder ones. And we want to use the complement rule because we don't really have a way of directly figuring out the probability of getting it on at least one of the tosses. I mean, I guess technically we could, right? What are the possibilities? We can get at least one. So one head, so like heads, tails, 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 right? Or I could get heads, heads, tails, tails. 4 times. Or I could get, that's at least, heads, 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 tails. Or I could get heads, 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 heads. Those all count. But each of these have multiple combinations and permutations, right? Because that could actually be heads, heads, tails, heads. That counts. Heads, tails, heads, heads. Oh my gosh. Like, I literally have to figure all those out and add them all up. Yes. Or just use the complement rule. Because the direct approach to this question is hard and time consuming to do in less than 2 minutes. But what if instead I say, well, the probability of at least one heads equals 1 minus the probability of not at least one heads. Is that easier? What does that mean? Let's translate that. Somebody try to type in the chat area, like, what does it mean to not even get even one heads? Not at least one. We're not getting any heads, like not at least one heads. No heads. So what's another way to say no heads, Emma and Dean? All tails. Make sense? Exactly. So not at least one heads means no heads, which is the same as all tails. Do I have a way to do that? So the probability of at least one heads is 1 minus the probability of 4 tails. In a row, do we have a formula for that? Yes. Rule number 2, when in doubt, multiply stuff. So the probability of tails, 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 tails is 1/2 times 1/2 times 1/2 times 1/2. I have a rule for that. I can do that. Make sense? That's easy. This is hard. This is easy. So the answer to the question is what? 1 minus 1/2, half, 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 2, 4, 8, 16, 1/16. So 1 minus 1/16 is? For those of you still paying attention, 15/16. Answer choice E. Yeah, very good. I like the student feedback, so I'll sit here as long as it takes for one of you guys to chime in. And let me say something else really quickly. I'll put it up on the screen. Probability is one of the question types. Just file this away. If a probability, especially a hard probability question, pops up on your computer screen and you don't immediately know how to proceed, probability questions tend to be the easiest questions to use logic and common sense to eliminate clearly wrong answer choices, so that at the very least you can improve your guessing odds. And what I mean by that is even just asking yourself something like, is it likely or not likely, is enough to decide, is it going to be like a small number or a big number, right? So here, there's a big difference between 1/4, which means not very likely at all, and 15/16, which means almost certain. So on that spectrum between, like 0%, 50%, 100%, where am I likely to be here? If I give you 4 chances and all you have to do is just get 1 heads, I'm giving you 4 chances. The probability of getting a heads even just once is 1/2, but I'm giving you 4 chances. It's probably pretty darn likely. Like, we're definitely somewhere up here. Does that make sense? Because 1/2 is the probability of getting a heads on 1 flip, but I'm giving you 4 tries to just get 1 heads. Yeah, very likely. So we can eliminate A and B just because we're over on the very likely side of the spectrum. Does it make sense? So at worst, you've improved your guessing odds. And at best, you know how to do the problem, or you err on the side of, this is actually probably very likely I'm going to guess answer choice E, but now you see how to actually do the question itself. So don't forget this tip on probability questions, is that common sense can go a long way. All right. So, dun dun dun. With that, now let's see who has been paying attention and how to use the building blocks that we just learned to go back to question number 1, this hard GMAT probability question, and see how all of these pieces fit together, right? So I'm just going to kind of dive in the interest of time. We only have about 10 minutes left before I want to try to wrap this thing up. But I want to show you how I would be incredibly systematic with a question like this on my scratch paper. Because I think the more crystal clear you can get on your scratch paper, thinking about, rule number 1, rule number 2, and rule number 3, and write it out in a way that systematically makes it logical for you to understand what's happening, the better off you will be, right? So let's skip right to the question itself. And the question itself says, okay, we want to know the probability that Harry will be either secretary or treasurer. All right? And so when in doubt, just start writing out what you can. One of the analogies I use with my students all the time is the idea of driving through the fog with headlights. Sometimes we look at a question and feel overwhelmed. Like a question like this, you might think, oh my gosh, there's so many moving parts. I have no idea what's going on, blah. But same thing if you're driving through the fog with headlights on, you can't see all the way to your destination, but you can see just as far as your headlights will let you go, right? And a funny thing happens. If you drive just as far as your headlights will let you go, you've gone a little bit further. And oh, by the way, now you can see a little bit further. So now you drive that far. And then you're a little bit further. And then you can drive a little bit further. And the next thing you know, you are to the destination that you couldn't see in the beginning, but you somehow got there anyway. And so one of the things I always tell my students is, if you're feeling stuck, just start doing something, and you might see how the rest of the problem unfolds. So here's what I can do at the very least. I can say, okay, I want to know what the probability of being a secretary or treasurer is. Okay. Well, more headlights. I remember Brett's rule number 2 that says or means add. So I'm going to say, okay, that's the same thing as the probability of him becoming the secretary plus the probability of him becoming the treasurer. Now, are they mutually exclusive or not mutually exclusive? Right? You can't be the secretary and treasurer at the same time. So we don't have to subtract anything out. It's just the probability of secretary plus the probability of treasurer. We're going to add those things up. Okay, I can do that. Now let's get even more specific. What's the probability that he is secretary? And I'll give you a hint. It is not 1 out of 9. So it says 1 of the remaining 9 will be chosen secretary, but his probability of becoming secretary is not just 1/9. And why not? It's not 1/90th either, but Ryan, you're on the right track because you are accounting for something. What are you accounting for, Ryan? Exactly. So here's what's happening. We are selecting members of the cabinet, but the first thing that happens is the president is selected. So for him to be chosen secretary, that is the same thing as him being not president. So first he has to avoid being president, because if he's picked president, now he can't be secretary. So he has to first not be picked president and then secretary. Make sense? So that's like how we're going to figure out the probability of becoming secretary part. Plus, now let's figure out the probability of treasurer part. Well, that's the probability of not president and then not secretary. He's got to somehow avoid both of those and then be picked treasurer. Make sense? Now I think we're ready to actually solve the problem. And look what's going on. Do you see how helpful like the last 45 minutes of your life was? Because we have these building blocks. Not becoming president, that's rule number 3. The and situation, that's rule number 2. The or situation, that's rule number 2. The individual probabilities, right? That's rule number 1. So let's talk about it. Let's look at his probability of becoming secretary first. What is the probability that he is not chosen president? This is an example of like the rain versus not rain situation. Yeah, it's 9/10. Like we didn't even necessarily need to do the 1 minus formula. We just know that if the probability of him being president right out of the gate would be 1/10, then the probability of him not being president would be 9/10, right? And then multiply, okay, like we avoided being the president. Now let's be chosen secretary. Now rule number 1 says, what's the denominator? Total outcomes. Total outcomes are now just the remaining 9 members because somebody, not Harry, has already been chosen president. So now that it becomes time to pick the secretary, there's only 9 total people left and 1 Harry. So now his chance, he's the one favorable outcome out of those 9 total possibilities to become secretary. So that is the probability that he is chosen secretary. 9/10 chance that he's not president, and then 1/9 chance that he is the secretary. All right? Now, let's add to that his probability of becoming treasurer. Yeah, exactly. And that does work out to 1/10, Ryan. So the 9s cancel. So 1/10. 1/10 chance that he's going to be secretary. Now for the treasurer part, he's not going to be chosen president. We already figured that out. Now, of the remaining 9, he's not going to be chosen secretary. So 8 of those 9 are not him. So 8/9 chance that he's not secretary. And oh, by the way, now of the remaining 8, yes, he is treasurer. And so that, the 9s cancel, the 8s cancel. Hey, look at that. That is also a 1/10 chance. And now 1/10 plus 1/10 equals 2/10 equals 1/5, answer choice E. So you might be looking at this saying, that was a lot of work. Not really. Once you did this, you should be able to do this in like 10 seconds, 15, 20 seconds, right? So as long as you knew what all of these rules were and you were crystal clear on your scratch paper about what we're trying to actually do, it's not a hard problem. The GMAT thinks it's a hard problem. This is the type of question that could get you a 700, but now we have the building blocks and the all-important complement rule to help you along the way. Because don't forget, almost always the really hard probability questions are going to have some complement rule aspect to them. And here it was remembering that he has to first not be chosen president before he can be chosen secretary. All right. So I told you that it was going to be a whirlwind, that I was going to try to pack like hours worth of my probability lessons in my course into, 45 minutes to an hour. And so there we are. Like I said, if that didn't make a ton of sense to you or you got lost on some of those questions, I will be sending out a replay link hopefully tomorrow. So would this be kind of, no, probably not one of the hardest, but definitely harder. I would say it's a low 700 level question though. It's hard to think of what would make it much harder. Question number 7 actually is, I think, harder, the at most version. And as you can see, I didn't get time to get to it tonight. So what I will do is I will go back to my recording. I'll sit down here either tonight or tomorrow, and I'll just record a solution to question number 7, which is an at most question. And it's even a little bit harder than the at least question and a little bit harder than that. And it would definitely be a 700 level question. So yeah, they can get a little bit harder, Ryan, but it's definitely, that one was considered certainly a harder question, upper 600, lower 700. And like I said, I'll send you a solution to question number 7. But by the way, you may have a fighting chance at it now that I've taught you the at least example, because everything we did with the at least example applies on the at most question. So try question number 7 on your own, and then I'll send out a solution to you in the next day or two for that. All right. So a lot of you are asking kind of like what next. Obviously, probability is only one side of the probability and combinatorics coin. So you got combinatorics you got to learn, all the other math stuff, all the other verbal stuff, everything obviously to get a high score on the GMAT. This is just only one component of it. And you might be thinking you do want to go deeper. So I promised a special offer plus a free giveaway. And the offer is very simple. For people on this webinar, I'm going to offer a 15% discount, which is a bigger discount than I almost ever offer on my full GMAT prep course. The course is already incredibly competitively priced in the industry. So that's why I don't really offer a whole lot of discounts, because it's already, usually about 50% less than most other courses in the industry anyway. But I'll offer an additional 15% off of the full prep course. Yeah, so the probability is treated in a little bit more detail, plus Pensash, all of the combinatoric stuff, plus obviously everything else in the entire GMAT. And so 15% off the full prep course, and just as a limited kind of one-time bonus, just because we talked about probability tonight, I'll send you a copy of the Little Purple Probability book that I mentioned earlier, which is another book that's even more in depth on some cool probability stuff. So very simply at checkout, use the coupon code GMATSAVE15. It'll be valid through the end of this week, so Friday at midnight. For those of you who are kind of new to me and what I'm about and kind of what the course is about, the full course is my comprehensive, complete course that covers obviously not only all the rest of the quantitative stuff, but all of the full verbal lessons. So all of the sentence correction and how to analyze arguments for critical reasoning and how to read passages effectively for reading comprehension, and just absolutely everything you would need to know, focusing a lot on the big rocks. So think about that analogy earlier. I'm going to build the big rocks first, but then, oh, by the way, we'll definitely get into harder, more kind of the sand and the 700 level concepts and stuff like that in the course, obviously. But it's going to take the guesswork out of preparing for the GMAT for you. It's a step-by-step study plan, a detailed course syllabus with all of my instructional videos, lots of practice worksheets to give you practice applications, including, by the way, for this probability, a whole worksheet on probability and combinatorics questions. You'll learn all those non-standard strategies I was talking about, the big rocks. score improvement guarantee, et cetera, et cetera, et cetera. But I think the biggest thing is kind of the increased confidence. And one of my former students, Kirill, I wanted to share kind of what he had to say. You can kind of pause it and read this if you want, but I highlighted the part that I thought was most kind of important. He said, look, one of the main things I got out of your course was that I was able to finally, for the first time, overcome my anxiety. And I went into the test more focused than I had the 3 previous times. So he had taken the GMAT 3 times before finally finding me in my course, and finally was able to boost his score. And he credits it a lot to just knowing how to get started, having confidence when he sat down and knowing how to proceed. And he said, look, now I'm going to business school. And that was the point after all. Remember, kind of the means to an end. So I have 3 different package options designed to meet different needs. My base course is the silver package, ordinarily $297. Like I said, very inexpensive in the market to begin with, but you can save $45 with the coupon code at the bottom of the screen. And the silver package is going to be the baseline course that's going to cover absolutely everything, all of my videos and worksheets and just everything you need to do well on the GMAT. But with the gold package, I add a couple of extra things. So with the gold package, you're going to get all the video lessons and everything. Plus, I send you 2 course textbooks. The official guide to the GRE textbook from the makers of the GMAT, plus the book I mentioned earlier by Brandon Royal called Ace the GMAT. So I include that with the gold package because I think it's really important to have the official guide as a source of practice problems. I also like Brandon Royal's book, and with the gold package, I include 2 additional of my full-length computer adaptive practice tests. So you'll get the textbooks plus some extra practice tests with the gold package. If you already have the official guide, some students already have a lot of textbooks and have practice tests, just go with the silver package. It's totally good. Silver package is great. But with the gold package, I throw in the textbooks and some extra practice tests. The platinum package is the base course plus the textbooks, extra practice test, and I host a live online office hours session on Wednesday nights. It's a format kind of like this. We use this interactive platform, and we just go through your questions. So if you have questions from the homework or practice test or just anything, I just show up and I answer questions and help you get through your sticking points and stuff like that. And that's available on Wednesday nights to Platinum Package members. That's even at $497. That's all it is for our premium package. You'll save $75 with the coupon code that you see at the bottom of your screen. Plus, as I mentioned, I'll throw in Brandon's The Little Purple Probability Book. 30-day money-back guarantee. I've never once had a student ask for his or her money back, so not too worried about that. But if you want a little assurance, there it is. And like I said, this offer expires Friday at midnight. So with that, I think I'm going to wind things down. I hope you found it helpful. Covered a lot of material, like I said, but hopefully it's really been eye-opening for you. I hope you have just a better sense of how to proceed when a probability question pops up on your screen. And I think now you have the tools and the building blocks for obviously the easy and the medium questions, but you definitely have the tools you'll need for the harder questions as well. So with that, as promised, let me go ahead